Hello everyone. My name is Sheikh Mohammad Fawaz. I'm studying in Sri Venkateshwara College of Engineering. I'm currently pursuing my engineering in AI ML that in seventh semester. So my today's topic will be in subject AI and ML. So the topic for the day is K nearest neighbor learning. So we'll be reviewing the K nearest neighbor the algorithm, which is a very important algorithm of ML. So in this presentation, we learn into and we deep dive into K nearest neighbor learning, a foundational algorithm in machine learning. Will cover its core principles, practical applications, and considerations for implementation. So we'll understand how this algorithm works and what are the key principles of it, and we'll see the real world applications of this algorithm. So first, let's understand what does K nearest neighbor mean. So let's take a practical example of you are going to vote in an election. So let's say we want to predict who are you going to vote. So only by knowing your name and your personal details we can predict up to a certain extent. So let's say we know your locality, your neighborhood, and you know the similar likings compared to the people around you. So then the nearest neighbors also influence the factor that whom you're going to vote in an election. So using that information of your neighbors or your surroundings, we can predict the person you're going to vote. This algorithm is based on the similar logic or similar approach. So this is how the K nearest neighbor algorithm works. So let's get understanding with what are the basics. So KNN is a basic non-parametric supervised learning algorithm used for both classification and regression tasks. It makes predictions based on the similarity of data points in a feature space. So let's consider the feature space as the locality or your neighborhood, and similar points are between you and your neighbors. So this is the live example we consider for a KNN, this one algorithm. So the core idea of this algorithm is KNN finds the K nearest data points of a new data point and uses these neighbors to determine its class or value. The K is the user defined parameter. So like we discussed, so for predicting who your user or you are going to vote in an election, we will be relying on the user specific information or detail, that is a parameter, and we'll be predicting the outcome of the election. So this is how K nearest neighbor works. So its fundamental concept of KNN is neighborhood voting. So like we discussed now, for classification it is used. That is, KNN predicts the class of a new data point by considering the majority class among its nearest neighbors. So that is one example, and it is also used for regression. So KNN predicts the value of a new data point by averaging the value of its K nearest neighbors. So it takes into the consideration for regression task as well as classification task. Also, it is used for proximity. The key principle of KNN is that similar data points tend to have similar properties, and hence we can predict the proximal values of that particular data point. So distance metrics in KNN. So we have when we have data points in the neighborhood, we use the distance matrices to calculate the distance between each data point. So these are the neighboring data points compared to the target data point. So different data matrices are Euclidean distance, Manhattan distance, and Minkowski distance. So Euclidean distance is the most common metric, calculating the straight line distance between 2 points in a multidimensional space. Then Manhattan distance is the measure of sum of absolute difference between the coordinates of 2 points, resembling a city block pattern. So these two are very important distance matrices used, and Minkowski distance is also a generalized distance metric that encompasses both Euclidean and Manhattan distance with the parameter p to adjust the distance calculation. So it combines both Euclidean and Manhattan along with the distance parameter, that is p, which is used to modify the calculation. So choosing the optimal K value. So the k value is the significant. It is very important. It significantly influences the KNN's performance, impacting both accuracy and bias. Too small, so a small k value can lead to high variance, resulting in a model that is sensitive to noise. So there is bias and variance. So a small value can lead to very high bias variance, that is it can be very sensitive to noise and it can overtrain the model. A large k value can lead to high bias, creating the model that is less sensitive to local variations. So it becomes less effective to noise, and also it will become more bias. It starts overfitting on the data, and it doesn't learn to the new incoming data. Finding the sweet spot. So strategies like cross validations are used to find the balance between the bias and variance. So we need to find the striking balance between the bias and the variance for the optimal k value. So we have advantages of KNN. The KNN advantages are, it is very simple. KNN is easy to understand and implement, requiring minimal parameter tuning. So versatility is, it can be applied to both classification and regression tasks, making it adaptable to various problems. KNN does not make assumptions about underlying data distribution, making it robust to complex data patterns. And it is also a lazy learning, that is KNN does not require explicit data training, storing all data and points to perform the predictions. So these are all the advantages of KNN algorithm. So the limitations are the curse of dimensionality, that is in higher dimensional space the distance becomes meaningless. uh, and the sensitivity to outliners, so they are very so we have to basically clean the data before we are training the KNN. So the outliners are the extreme data points that can significantly affect the KNN algorithm. And computational cost is very expensive for large data sets, as it requires calculating distance between every data point for predicting the values. Applications, like I said, in voting, image recognition, recommendation systems, medical diagnostics, credit risk analysis, assessment, etc. So implementation of KNN is, we can use the scikit-learn's library, which provides a detailed class wrapper, which we can use for KNN implementation. So this is how we can compare KNN with other machine learning algorithms. I hope you understood the topics. Thank you.